This is the last section for topic 4, and it's section 4.6, and it says congruence in overlapping triangles. Now this might be the toughest one for us to visualize and to see, because you're going to see overlapping triangles. Those are triangles that are kind of parts of it are laying on top of each other. And visually, mentally, you got to try to separate these triangles, which is not always an easy thing to do. So cut yourself some slack, but give it a shot. So it says identify the corresponding parts of the overlapping triangles, triangle ABC and triangle DCB. So let's try to look at these triangles individually. First off, triangle ABC. So here's triangle A to B over to C. Okay, so that triangle is in red. That's triangle ABC. Now I'm going to switch colors. And I'm going to go to black because that's probably the next easiest color to see. Actually, I'm going to make it blue. Let's see if we can see this. And then I'm going to take triangle DCB and I'm going to make it blue. So here's triangle D to C to B. Okay, so that's triangle DCB. So you can see that there's a portion of that triangle that's overlapping. So if you want to, you can try to visualize pulling those two triangles apart. And it says segment AB corresponds to what? So if I were to take this red triangle and flip it so that it was laying on top of the blue triangle, segment AB, this segment right here, would match up with which segment? Well, it would match up over here at DC. Okay, go ahead and write that in your packet. Segment BC, so this segment down here, if I were to take that red triangle and flip it over, which side would it match up to? Well, it's still going to match up to CB. Or if you say BC, again, you can always change these letters around, and you're still talking about the same segment. And segment AC, so from A to C is this hypotenuse right here. If I were to take that and flip it over, that segment would line up with DB. Okay, so those would be the segments that would line up with each other. Okay, angle ABC, angle A to B to C. That's the 90-degree angle right here. If I took that and flipped it over, well, it would match up with this 90-degree angle over here. So we're going to call that angle DCB. Okay, angle CAB, angle C to A to B. That's this angle up top here. So if I were to flip that over, this angle up top here would match up with this angle up here. I'm going to call that CDB. And ACB, A to C to B, is this angle right down here. So if I flip that red triangle over, this angle is going to come over here. So I'm going to say that's angle CBD. And those would be the pieces that would match up with each other. And so sometimes it's hard to visualize that. If you have different colored markers or pencils or crayons at home, you may want to get those out so that you can identify the separate triangles that we're trying to talk about and we're trying to match up. That would be helpful to you. It says, which of these are congruent pairs? Okay, well, we know that AB is congruent to, it says that segment AB, it's got a tick mark here, is congruent to segment DC. We know that because we see one tick mark in the drawing. And we know that angle B down here is congruent to angle C over here. Okay, because they're both right angles, so they have to be congruent to each other. And then they're sharing a side down here at the bottom. You can see the red line is part of the bottom of the rectangle, and the blue line is also part of the bottom of the rectangle. They're sharing that side. So we would say that BC is congruent to CB. Okay, so those are the congruent pairs that we know of, and it says, do these satisfy any of the criteria for determining that the triangles are congruent? Even though they're right triangles, the hypotenuse leg, that HL that we just talked about in the previous section, is not in play here, because the hypotenuse would be A to C and D to B, and I do not know, that's not what I've listed as knowing as congruent. So hypotenuse leg doesn't apply here, but what does apply here is you have the side, you have the angle, and then you have the side. So by SAS, we would have two congruent triangles. The red triangle and the blue triangle would be congruent to each other. But this time it wouldn't be HL, but it would be SAS, side angle side. Okay, so you have to be careful of that. Don't assume that if it's a right triangle, it has to be HL. It can still be those other four that we've already talked about, the SSS, the SAS, the ASA, or the AAS. Don't assume that it has to be HL. It can be, but in this case, it's not. Okay, let's look at the proof here. Okay, we are being asked to prove that two triangles are congruent to each other, and we're given a lot of information here. So again, we always want to start with the given information, and they just copied that down just as it is, and your reason over here would be, well, that's a given. And once again, I keep saying this is kind of like a broken record. Whatever you see listed here in the given, you want to go over to your picture, and you want to mark it down. So it says segment AB, here's segment AB, is congruent to segment DC. So those two segments are congruent. Segment AF, this segment right here, is congruent to segment DE. And it says angle A, we do arc marks for angles, angle A is congruent to angle D. Now what we're trying to prove, okay, you can see that little triangle there and you can see that little triangle there, but that's not what we're trying to prove. Okay, right here it's telling us we're trying to prove that triangle ABE. Okay, so here's from A to B over to E. That triangle right there, that's ABE, is congruent to triangle DCF. Here's D, up to C, and down to F. Okay, those are the two triangles that we're trying to prove congruent. The black triangle here and the blue triangle there. Okay, so I've copied down the given and I've marked it in my picture. And then it says segment FE is congruent to segment EF. Okay, FE, so FE is this piece right here. FE is congruent to EF. Well, why is that congruent? Well, if you'll notice it's got a black line under it and it's got a blue line under it. That's the same segment and it's part of both triangles. So just as we've seen many, many times, that segment is congruent to itself. That's the reflexive property, or a shared side. Okay, that's still the reflexive property. Okay, and then they got something different. We haven't seen this for a while, but it says segment AE, so from A right here all the way across to E, that whole bottom of the black triangle is equal to this AF plus the FE. So this little black section plus this little blue section equals the whole side of the black triangle. I think you can see that in the picture. And then it says segment DF, this blue segment over here, is equal to DE, that's in blue, plus the EF. So if you take the segments here that have already been marked congruent and you add the same piece to them, aren't they going to be congruent to each other? We call that the segment addition postulate, where we're just adding two segments together. So they're adding these two segments together in the black triangle. They're adding these two segments together in the blue triangle. That's the segment addition postulate. Okay, then they're going on to say that segment AE is congruent to DF. So this bottom black line of the triangle is congruent to the blue bottom of the triangle. And that is the substitution, or the transitive property. What they're doing is they're substituting. They're saying that AF and DE, we already know that AF and D, we already know that these two things are equal to each other. That was given to me. And then we're essentially adding the same thing to them. Same thing in an equation. If you add 5 to both sides of the equation, you still have equality. They're still equal. So here, these are the same thing, and I'm adding the same thing to them. Therefore, these two things are equal to each other. That we call the transitive property, or substitution. And if I know that this side down here is congruent to this side in blue, then I know that the triangles are congruent. I could say triangle ABE is congruent to triangle DCF. And what would my reason be? Well, I have a side, I have an angle, and then I just proved that this side was congruent to the blue side. So it'd be by side angle side. And I would know that the black triangle is congruent to the blue triangle by SAS. Okay, your proofs are going to get like this. And again, you've got 5 different reasons for proving the triangles are congruent. Keep working at it. I know this isn't easy, but keep working at it. Put your thoughts down on paper. Make sure you copy down the given and you copy down the proof statement. And as you have questions, be joining those Zoom meetings so we can get your questions answered.